Hello friends, today we'll see the problems on resultant of parallel forces in space. Probably one of the easiest part if we know how to solve these problems. And if we know the techniques of solving the problems, then we'll enjoy these examples. Simply what we have to do. So if parallel forces are there, either they will be parallel to x-axis, y-axis or z-axis. Hence, very first step is what? For getting the magnitude and direction. Simply we have to use r is equal to summation f. If those are parallel to x, summation fx. Parallel to y, summation fy. And parallel to z, summation fz. Like that. And by only this one step, we'll get the magnitude and their direction. The direction of the resultant. Then for locating the resultant, we have to use twice Varignon's theorem. And all this I'll explain while solving the problems on this part only. So now we'll see the examples on it. Now we'll see the very first example of resultant of parallel forces. The example is what? A square foundation mat supports 4 columns as shown in figure. Determine the magnitude and point of application of resultant. So these are the 4 forces. It is x-axis, it is z-axis, means by default from this there will be y-axis. Correct? And so such sketch will be there in the question. Then while solving, what we have to do? So you need to draw that sketch in the solution also. And in the solution, how I can draw this sketch? Observe it very carefully that it is a square foundation mat. Means it is going to be a square. So in 3-dimensional, it will be like rhombus. And now, so it is what? It is shown that it is the z-axis. It is z-axis. And along this line, it is x-axis. It is x-axis. Hence, the perpendicular to it, it will be automatically y-axis. So you have to draw this sketch. And at a distance of 4, if it is 10, at a distance of 4, there is 20 Newton force in downward direction, 20 kilonewton. See, very simplified sketch I am drawing. So it is 4 meter, it is 6 meter. And this is also 10, square means it is also 10. And here, how much force is acting? 16 Newton. That weight, 16 kilonewton. And it is 5 meter, it is 5 meter. Correct. And again, 2 forces or 2 columns are there. One is at this place, its value is 80 kilonewton. And one will be at this corner, 24 kilonewton. 24 kilonewton. So this is going to be the sketch you are supposed to draw in the exam also. Then what we have to do? Let's see it. Once we are having this sketch, then very first step in the resultant of parallel forces is what? R is equal to. All these forces are parallel to y-axis. Summation fx and summation fz is 0. Means r is equal to summation fy. And if it is summation fy, just see these 4 forces are there. Downward direction, minus 80, minus 20, minus 16 and minus 24. Means it is going to be 140, minus 140. R is equal to minus 140, and hence the resultant magnitude is 140 kilonewton. So this is the magnitude. And its direction is going to be negative, means in negative y direction. It is vertically downward or like this, downward. Finish. And even though if suppose this problem is for 8 marks, then 4 marks you will be getting only for this. So that is why it is a gift. Probably the easiest part of the mechanics, at least this much portion. 2, 3 or 4 marks any student will get. Then after that, what I have told? Use twice Varignon's theorem. Means before that, what you do? So you assume that resultant is acting somewhere in this square plate. Then let us consider that, so it is acting like this. So anyway, it is going to be vertically downward. R is equal to 140 kilonewton. And now see, this is going to be a origin. This is going to be origin, means towards x it is x coordinate, and towards z it is the z coordinate. Its y coordinate is going to be 0. Means this resultant is acting at P and its coordinates are xz, which we have to calculate. So these two coordinates we have to calculate. Then how we can calculate these two coordinates? By using, directly you can write, by using Varignon's theorem. Varignon's theorem means instead of writing twice, only you write once. And initially we use the Varignon's theorem about z-axis, so that we'll get x coordinate. Means first, by using Varignon's theorem about z-axis. And about z-axis, how we can use, one side is going to be moment of the resultant, r into x. And earlier also I have told, I'll always consider clockwise moment as positive, anti-clockwise as negatives. Some of you can means take anti-clockwise positive and clockwise negative. That is also not wrong. Then the moment of the resultant about z-axis. In space forces, instead of point, we have to consider the line or axis. Then it is going to be about z-axis. One side is going to be 140 into x, moment of the resultant, and its right hand side will be what? Its right hand side is going to be moment of all the forces about the same axis. Moment of 80 is 0. Moment of 20 into 4 plus 16 into 10 plus it is 24 into 10. Means actually it is 40 into 10, 400 plus 80, 480 divided by 140. It's 3.428, means 3.43. X is going to be 3.43 meters. It is the x coordinate. And for getting the y coordinate, what we have to do? So we have to use the same Varignon's theorem about this x-axis. Means if we are looking from this, so this is shown is the x-axis. Then about x-axis, I am writing simply x-axis, and see the moment of resultant about x-axis. So now just see that it is the x-axis and it is the z-axis. So just I'll make a slight change in the sketch, that is going to be like this. Actually this z coordinate, so from the x-axis this is z, so it is not the z. So we can remove this. This is z from x-axis towards z-axis, that is z coordinate, and from z-axis towards it is. Then how I can use this Varignon's theorem about x-axis, the moment of the resultant, again it is clockwise, 140 into z is equal to moment of all the forces. On x-axis 20 Newton is there. Then what will be the moment of 16 into 5 plus 24 into 10 plus 80 into 10. Then what will be z? Z is going to be 1040 plus 80 divided by 140. So it is going to be 8. Z is going to be 8 meters. So this is the z coordinate. And in the answer you can write this answer that R is going to be 140 kilonewton acting vertically downward, and it is acting at point P. X coordinate is 3.43 meters, Y coordinate is 0, and Z coordinate is 8 meters. This is the complete answer. So by such a very simple way, we can solve the problems of resultant of parallel forces in space. Now we'll see the second problem on resultant of parallel forces. Again, here also we have to find out, determine the magnitude, direction and point of application of the resultant. So this is the x-axis, this is z-axis, means by default it is going to be y-axis. First, what I'll do, so I'll draw this sketch. So in the exam, so you cannot locate this resultant in the question paper. So anyway, you will have to draw the sketch. Then how we can draw this sketch? See, it is the y-axis vertical. Then in this direction there is a x-axis, and in this direction there is z-axis. So these are the three axes, and it is a again square. So it's 5 by 5. So at a distance of 2 meters, from this, a force of 100 Newton. So it is 100 kilonewton. So it's 2 meter, and this distance is 3 meter. Again, exactly at the center, vertically downward forces, it is 40 kilonewton, and this is 2.5 meter, 2.5 meter. Correct. It's 40 kilonewton. Then at the origin, it is 200 kilonewton. And at this point, at this corner, again vertically downward, it's 60 kilonewton. 60 kilonewton. So just I have drawn the figure because we have to locate the resultant, it is required. X, Z, and it is going to be y-axis. Then what we are supposed to do? Again, it's very simple. R is equal to summation F and use twice Varignon's theorem. That's all. So here R is going to be summation again Fy, because all these forces are acting in y direction only. Then we'll start with 200 minus 200 minus 100 minus 40 minus 60, means it is minus 400. So R is going to be, its magnitude is going to be 400 kilonewton. So this is the magnitude, means one answer. Second, direction vertically downward. So it is vertically downward. Two answers are finished. Then for getting the location by using Varignon's theorem. Again, for that also, what we need? So we need that we should consider this, that somewhere the resultant is acting like this. So this is what the resultant. R is going to be 400 kilonewton vertically downward. So in the direction of x-axis, it is x coordinate, it is z coordinate, and for P we have to get this xz coordinate. Finish. Then, so by using Varignon's theorem, means first we'll use about z-axis. How is the Varignon's theorem? Moment of the resultant 400 into x. It is clockwise about this. The moment of 200 is 0. Right hand side is moment of all its components. So 200 into 0, 100 into 2 plus 40 into 5 plus 60 into 5, means it is going to be, x is going to be This is 100 into 5, 500 plus 200. It is 700 divided by 400. It is 1.75. X is going to be 1.75 meters. Finish. And if we consider x-axis, and about x-axis, how is going to be Varignon's theorem? About x-axis, if we are standing over here, moment of resultant is going to be negative, anti-clockwise. It is going to be minus 400 into z. It is equal to moment of 260 is 0. Moment of 40 minus 40 into 2.5 minus 100 into 5 means 600 by 400. I think it's 1.5. Means calculations are very simple. Z is going to be 1.5 meter. Means the resultant magnitude of the resultant is 400 kilonewton. It is vertically downward and it is acting at point P, where x coordinate is 1.75 meter, y coordinate is 0 and z coordinate is 1.5 meter. Finish. This is the point of application of the resultant and it is the simple solution of this problem. Now we'll see the third example. Again the question is going to be same. Find the resultant of parallel force system which act on the plane as shown in figure. So this figure is little bit complicated. The same figure you have to redraw in the solution like this. I have drawn this. The same figure. And then after this, what you are supposed to do? You have to solve this problem like this. All these forces, these are parallel to y-axis. Means R is going to be summation Fy once again. Then see, 500 is towards positive y, 500 plus 300 towards positive plus 200 minus 50. So this is opposite and hence R is going to be 950 and its magnitude is going to be 950 Newton and its direction will be as positive, so it is something like this, towards positive y direction or towards positive y-axis. This is the direction. You can write like this. And for getting its point of application, by using Varignon's theorem. Then for using the Varignon's theorem, what we have to do? Just see it. So the major forces are in this quadrant. I feel the resultant will lie somewhere in this quadrant. Means it will be like this. It is R. So from z axis towards x, it is x. And from x axis towards z, it is z. It is z. And this point is going to be P. Point of application. Then about z axis first. About z axis, what is the moment of resultant? It is going to be clockwise. It is going to be 950 into x. It is equal to moment of 500 and 300 is 0. Moment of 200 into 0.5. Again 50 also, its moment about z axis clockwise only. 50 into 0.5 means 250 into 0.5 divided by 950. It's 0.132. 0.132 meters. It is x. And how to get z? So for that we'll have to use this Varignon's theorem about the x-axis. About x-axis. About x-axis. Moment of resultant. Again about x-axis, it is going to be clockwise. So it will be 950 into Z. It is equal to moment of 500, 200, it is 0. The moment of 300 into 0.35 plus again 50 also the same moment, 50 into 0.35. So it is 350 into 0.35, 350 into 0.35 divided by 950. Z is going to be 0.129 meter. So this is the location, and if you see this neatly, if that P point is there, we can write this. Now positive x, if it is towards this, means this x is negative minus 0.132 meters, comma. So it is in xz plane, that's why y coordinate is 0, and z coordinate again it is below origin, negative minus 0.129 meter. So like this you can easily solve the problems of resultant of parallel forces. Only two basic steps you have to remember. R is equal to summation F, and then use twice Varignon's theorem. That's all. I think you will enjoy all these three problems of parallel forces in space. Thank you.